Hi, I'm Brian Hirsch. Welcome to AgileGov livestream number 2. I run an accelerator program called AgileGov for people in government working to improve digital public services. In the grand scheme of things, the internet is still pretty new, and we still have a lot to figure out about how government should work in the digital age. People are innovating and uncovering better ways of delivering public services constantly, and I want to hear their stories and insights. And I want to help successful approaches circulate faster to make it easier for all of us to build on what works and to spend our headaches on unsolved problems rather than reinventing wheels. So that's my basic vision for this live stream. If you're into this vision and you want to see more of these, please click the link below this video and take a minute before you go, whenever you leave, whether you stay till the end or not today, to leave a little bit of feedback and help us keep getting better at making these the best possible use of everyone's time. A couple housekeeping items before we jump in and bring on today's guest. We will pause a couple times throughout the conversation for questions. So if you didn't submit questions in advance, that's okay. Drop them in the chat and we'll get to as many as we can. We also got feedback from people who prefer not to log into YouTube to use the chat box. So today we also have a Google Doc where everyone should be able to access without logging into anything. And you can see the link on the screen. We're dropping the link in the chat. So if you prefer, you can drop questions in the doc. If you want to use the chat, and we'll see how that all goes. Okay, let's introduce our guest. So today I'm going to be talking with Rob Bayless about automated testing. Rob is the CTO of Mighty Acorn. And when I stepped out of the role of Director of Technology at Massachusetts Digital Service, Rob agreed to take responsibility for the security, scalability, and reliability of Mass Digital's infrastructure. And we were the first team in the cloud. We had the state's first AWS account. We were the first in the state to adopt infrastructure as code, to use serverless services. I don't know if we were the first to implement automated release processes. We might have been. Rob and Last Call Media, the company that he worked for at that time, were critical to launching and operating sites like Mass.Gov, PaidLeave.Mass.Gov, the state's first multilingual unemployment.mass.gov. And so while today's topic is automated testing, the whole point of automated testing is to be able to make improvements to a system without compromising its reliability. And so Rob is not only expert in the testing tools and tactics that you'll hear about from him today, but he's been responsible for the reliability of some really big applications under difficult circumstances. And so his opinions are not only grounded in ability to implement, but also in responsibility for the outcomes. And this is one of the reasons I value his opinion so highly, and I'm really excited to be talking with him today. So let's go ahead and bring him on. Here he is. Rob, welcome.
Hey, thanks. Thanks. I'm excited to be here.
Thanks so much for being here.
Yeah.
So, Rob, I have learned so much from you over the years that we've worked together, and I thought it would be great to share some of your stories and insights with the world. I had this light bulb go off as I was getting organized for today's conversation to appreciate the different kinds of tests that I want you to talk about. People need to have some basic understanding of the different types of bugs that different tests can detect. So I thought we'd start our conversation off today by talking about bugs, and then we'll sort of follow you down the rabbit hole. Does that sound right?
Sure. Yeah, that's great. Yeah. Okay.
Well, sorry. Let me give you one sort of starting point.
Sure, yeah.
So anyone who's used a computer has interacted with a bug and an error message, right? Like software, when software doesn't work, when I click a button or a link and nothing happens, we all know that's a bug. Sometimes bugs come with error messages, sometimes they don't. I wonder if you could just start us off by helping us understand what's the relationship between bugs and error messages?
Yeah. Okay. Yeah, so this is a good one to kind of clarify up front. So when we talk about bugs, what we're talking about are issues that are affecting users of a web application. So that would be like, for example, when I visit the login form, I put in my credentials, I hit the submit button, and nothing happens. So I can't log in. That's a bug. By contrast, errors are anything that happens on the back end in the code to prevent normal execution, or they're basically a problem in the code, and they may cause bugs. So as an example of that, if in the login form code behind the scenes, I have called a function that no longer exists, when that login form is submitted, there may be an error that says, can't find this function. And so that may prevent the user from submitting the form. So the error is the underlying problem. The bug is what happens as a result. And those two are not always linked. You can also have bugs without errors. So for example, if someone had erroneously hidden the login form, so when you visit the login page, there's no username and password input there, that would be a bug that, there's not actually an error causing that. It's just, someone had made a mistake or a decision that caused a bug for a claimant, for a user of the system.
Great. Okay. So to recap, frequently bugs and errors come together, but sometimes bugs don't trigger errors. And is it also possible to have errors that don't actually mean that someone is experiencing a bug as an end user?
Absolutely. Yeah.
Okay.
Yeah. I mean, that's actually pretty common that, there might be small errors that are thrown in the generation of a page, and those don't actually impact anyone at all.
Yeah. Okay. All right. So if I'm, the owner of a website, let's say Mass.Gov,
Mm-hmm.
if some errors matter a lot and some errors don't mean that someone's having a bad experience, why not just ignore all the unimportant errors and just pay attention when a critical error happens?
Yeah, that's a good question. And conceptually, that makes sense, right? Like we only care about those critical errors, those ones that are preventing people from doing things. The problem becomes, well, it's twofold. Number one, how do you know? How do you know which ones are stopping people from doing things? There's not always a clear link between the two. And so as someone who's trying to maintain a website, I may have an error log that shows me all the errors that are thrown, but I might not have, or I definitely don't have the same sort of list of things that are affecting people on the site. And so it's hard to correlate the two and say like, all right, this error is causing this bug. So we tend to fix errors because we don't always know if they're affecting people. So that's thing number one. Thing number two is, it's like stepping into a room. If you step into a quiet room to have a conversation, it's very easy to hear. It's very easy to talk. If you step into a nightclub to have that same conversation, that's a very different conversation. You're yelling. You can't really hear what the other person is saying. Stepping into a project that has a lot of errors happening is a little bit like stepping into the nightclub. You can't always hear what you're trying to hear, and it's really hard to separate the signal from the noise and try and like get to the root of any particular issue.
Got it. Okay. All right. So now let's like drill into a real world scenario to sort of bring to life this like issue of signal versus noise. So I want to go back to September of 2017. The new Mass.Gov has just gone live with a new homepage and many of the state's most highly trafficked web pages. The old Mass.Gov is still running on unsupported software, and we're trying to get content out of the old Mass.Gov system, like getting people out of a burning building. And there are still 200,000 pages and documents sitting in the burning building. There are 450 authors and editors across 150 government organizations in Massachusetts that are learning how to use the new Mass.Gov, while we still have most of our content in the old one. And you are part of our platform team, and you're tasked with ensuring that Mass.Gov is reliable.
Yeah.
How reliable is Mass.Gov in the fall of 2017 when you're on the platform team?
I think it depends on your perspective. If you're sitting in that building, burning building, it looks pretty reliable. But if you're on the platform team, it doesn't look so reliable. I think it was reliable enough to launch a beta, which is what we were doing. And it is reliable enough to start moving things, which is, again, what we were doing. The kinds of problems that we were seeing were often triggered by new content being entered into the site. And so there would be, like brand new content that was either migrated or entered on Mass.Gov might have some sort of an issue or like it just might be structured differently than we were expecting. And the code hadn't sort of been tested to accommodate that yet. And I think we'll dig into some reasons or some of the things that were caused by issues like that later. But those were the kinds of things that we were seeing. It might have worked on day one, but as more content got added, things were getting increasingly unstable. And we had pages that were kind of inaccessible to people trying to visit them because we had a code error on that page that would produce a nasty something went wrong in generating this page. And so that's not a great experience for people visiting the site, and that's what we were most concerned with on the platform team.
Yeah, okay. So I wonder if we could just give people some concrete examples of the kinds of things that were triggering errors. The kinds of things that were triggering errors that the end user would experience and the kinds that they wouldn't. So like you gave the example of, I try to visit a page and I can't get to it. And then I see this If I'm remembering right, it was actually a beautiful page. It was made to
gorgeous,
look pretty.
Yeah.
And they even gave them a search bar. But it was we knew that was like an error. Okay, so I try to visit a page and I can't find it. Like that triggers an error. Can you just give another example of I'm finding the information that I need, but it's also generating errors on the back end that's making the platform team nervous about all the noise?
Yeah, sure. So it's hard to give an example without digging too deep into the weeds here, but just to give it a shot.
Yeah.
Let's imagine that we're building a page for the RMV, and the type of page that we're using expects a location field. And this particular RMV, we're building a page for like an online location of the RMV. So we're not entering a physical location, but the content is structured in a way that allows us to do that. So if we hadn't entered a physical location and the code was not structured properly, it might depend on that physical location being there, that data being there, and being able to output that information. And if we haven't guarded the code against that condition, the presence or absence of values in a particular place can really trip things up. And sometimes that can cause, one of those fatal errors like we were talking about. And sometimes it's just a warning that ends up in the log and is more noise for the platform team to look at.
Okay, so I'm a visitor to Mass.Gov and I need to figure out where to go to renew my driver's license. Yeah. I go look at locations, the locations listing for different RMV locations. Yeah. And my experience is mostly I'm finding locations and it's fine. Maybe sometimes I click a link and it doesn't work. But then your experience on the platform team is you're seeing this avalanche of errors, right?
Sure. Yeah, okay. Exactly.
So, and where are you seeing, so I know if I see an error message or not, I get to the page or I don't, and I don't worry about it if I get the page. What are you actually seeing for people who haven't seen error messages before? How do these end up in front of your eyeballs or the eyeballs of someone on the platform team?
Yeah. So these end up on our plate because we used a tool at that time called New Relic, which was a monitoring tool. And so basically all of the log information and all of the just a lot of data about the performance and scalability of the site gets entered into this platform and made visible. And so we had a dashboard that we would go into every day and we would pull up here's the list of things that we need to focus on. And part of that, every morning we would go through and we would look at these reports, and part of that was pulling out the error logs and making sure that there was nothing new in there.
Mm-hmm.
So it's pretty wild in there. And at that time, it was difficult to categorize things appropriately too, just due to the volume.
Mm-hmm.
So there's a lot to look at.
Okay. So early on, I remember a very high priority was to bring the noise down, right?
Mm-hmm.
Address a lot of those errors so that we can see, when we get an alert, we know if it's a critical alert and can respond accordingly, right?
Yep.
So can you just tell us a little bit about what it takes to actually do that and how you did that?
Yeah. So the first stab at it, of course, was just go in, find whatever we thought was the top offender for errors, what was affecting the most people, we thought, and fix that, which sounds great. We'll just push that fix out, and then we'll never see that error again. The problem is when we put that fix in, if we don't adequately test that, it fixes it everywhere, or it doesn't break anything everywhere else, we might break more things ourselves. And on top of that, we have, 6 other development teams. There were a lot of people developing on Mass.Gov at that time, pushing changes into the project at once. And so there was just a lot of, code change happening, and there was a lot of opportunity for new errors to slip in. So we might fix one and then 5 more pop up. And it was just really difficult to kind of get our hands around the problem and make sure that, we were heading in the right direction. And so knowing that was our issue, we started thinking about ways, we're reliant on actual people to go in and hit these pages for us to see these errors. That's a problem. Problem number 1. Problem number 2, we couldn't reliably replicate the errors in a lower environment. We were just having trouble seeing these errors anywhere but production, simply because they required, a lot of pages to be visited for us to find the right page. And it was a real needle in the haystack problem. So the solution that we came up with to try and get ahead of that and, detect these errors before they actually made it to production was to actually build a crawler and to have, basically, as we were preparing we had all the code that was committed for a day, and then we would push that up to an environment, and that was kind of like a draft version of the site. That was what would go live if we were to release the next day. And so we would visit, say, 5,000 pages in this environment, and we would visit them one by one, and we would see, did we get an error on that page? Nope. Did we get an error on the next one? All 5,000. And so we would do that same 5,000 consistently night after night, and it allowed us to sort of measure, number 1, and number 2, figure out the exact list of URLs that were causing problems. And because this tool ran nightly, someone on the team came up with the beautiful idea of naming it Nightcrawler. And so this is a tool that we wrote to fit that particular use case at that time.
Got it. And so so it sounds like there are a couple sort of purposes that Nightcrawler is serving.
Mm-hmm.
Partly it's making it sort of consistent. You can consistently see the errors, right? Rather than waiting to see who hits what page and actually trips an error, right? That's sort of one of the benefits.
Yeah.
Okay.
Yeah.
And then it's running every night. Can you talk a little bit about, I have the impression that, trying to fight against these errors making it into production can be sort of a game of whack-a-mole. Is that the right sort of impression? And how are you using Nightcrawler to prevent, you're not wanting to just drive the errors down, but you want to keep them at a manageable level.
Right.
So how did that work?
Yeah. Right. So because we ran this every night, we kind of had a baseline of all right, so here's Tuesday night was, we got 30 pages with errors, for example. And then Wednesday, if we had 31, we knew that something had happened between Tuesday and Wednesday that caused an additional error. Mm-hmm. And so if we pushed that code out, we were going to have at least one more page with an error, probably more. And so by knowing that like delta between each day, we were able to always keep directionally focused on like a little bit better and prevent releases on days when we knew, we would break more than we fixed that day. That answer your question?
Yeah, I think so. I'm also mindful of time, and I want to get to a couple more stories and also give people a chance
Sure.
to ask questions. So why don't we take a couple questions about Nightcrawler and the sort of the first example of automated testing and bugs, and then let's go on to a couple other things. So
Yeah.
here's a question: does Nightcrawler have to crawl the entire site, and how often does it run?
Mm-hmm. No, so Nightcrawler doesn't need to crawl the entire site. This is one distinction I want to make with automated testing in general, is that you're generally not actually headed for 100% coverage. We didn't need it was eventually like 200,000 plus pages of Mass.Gov crawled. We just needed a representative sample. And as long as that sample was big enough to be representative, we could be reasonably confident that we weren't going to see errors in like the long tail beyond that. As far as how often it ran, it was nightly at first, and then we integrated it into the release process. So there would be like a crawl as part of the release process to ensure that what we were about to release was checked immediately prior to going to production.
Nice. Should take one more. Do we have one more? Why does Nightcrawler run at night? Yeah, if it's not running in production, why does it run at night?
I mean, it's a cool name, first of all. But no, more seriously, it runs at night because it takes a while, and we're trying to pinpoint exactly what changes might have caused it. And so we knew we weren't going to have people working at night committing code. And so it allowed us a window where we had like a finite set of changes from the day before that were deployed to this lower environment. And then we could run the test, and it could take as long as it needed to. So we weren't guessing, was this in there? Was that in there? It was very clear what was in there and what wasn't.
Got it. Great. Okay, I'm going to push us ahead so we can hit another couple stories here. So we looked at examples of bugs that may or may not trigger errors. I wonder if now we can explore a different kind of bug and a different kind of test. Can you give us some examples of bugs that have existed or could exist on Mass.Gov that would be visible and frustrating to me as an end user, but that would not trigger an error?
Yeah.
They wouldn't be caught by Nightcrawler, but it's like really messing up my user experience as an end user.
Yeah. So, candidly, I'll be a little vulnerable here and talk about some of the mistakes. We had a lot of instances of things disappearing from pages early on, especially. So I'll talk about a more like high profile example of this in the future, but like a map disappearing from a location page, for example. And that may or may not be a big problem to a user, but it was intended to be there. It's supposed to be there, right? And so it usually isn't an error that causes that. It's not like a code problem. It may be, or it is a code problem, but it's not one that is like showing up in our error logs. We may have accidentally changed some styling somewhere that hid it. We may have accidentally changed some configuration. Usually it was something we didn't intend. So that things disappearing from pages is one, or another one could be like something showing up in the main navigation that we didn't expect. So those are two examples of things that are like not really errors, but you're going to notice.
Yeah. Okay. So you said something that I think is probably not totally intuitive. I just want to make sure I've got it and sort of restate it. So when you say we hid it in the CSS, so I think what you're getting at is that the code is doing its job. It's not triggering an alert. It's not triggering an error message because there's not something broken about the code that's running. So someone may have made an accident in code by setting it to hidden without realizing the effect that it would have. So it's sort of breaking the user experience, but the code's not broken, even if it's sort of not having the intended effect. Okay, so this feels like a gnarlier category of problem. Now, if this happens, would it be reasonable to assume that that if something is sort of visibly broken and it's not triggering an error, it's not raising an error, that like developers have done something wrong, that like someone has made a mistake?
I mean, sure. In that we're all fallible people. We made mistakes. Developers probably made a mistake for that to happen, but it happens. It's actually kind of impossible for it not to happen. A website is a very big place. There are a lot of places where things overlap kind of in ways you wouldn't expect. Just to follow that styling example, if something disappeared, it's probably because someone in another area of the site was working on something where they did need to make something disappear. And what they didn't realize is it shared logic with somewhere else on the site. So there's just a lot going on, and there's a lot of like overlapping things in a way that like no human could ever understand like the full implication of what they're doing. You can do as much QA as you want, but ultimately at the end of the day, it's really hard to catch this kind of thing. And also, you just don't really want humans to be doing this all the time. It's not the best way to spend their time.
Yeah. So smart people doing a good job,
Exactly.
just sort of this just sort of happens.
Yeah.
So how the heck do we create a test that can detect this kind of problem?
Well, I'm glad you asked. So we used a tool called Backstop. And Backstop is a visual regression testing tool. And what I mean when I say visual regression testing is visual regression testing means you go out and you take a screenshot of what the page looks like. So you open a browser and you take a screenshot, but like a computer is doing this for you, of a page on Mass.Gov, for example. And then the regression testing part is where we take a second screenshot at either a later date or of a different version of the site. And then we ask the computer to compare those two and say, like, are these pixel for pixel any different? And so it allows us to detect things like missing elements from pages, new menu items, any of that, like if there is styling breakage, things that look ugly on the page unexpectedly, it can detect that change and let you know, hey, you need to pay attention to this.
Mm-hmm. Can you tell us a little bit about how you set that up on Mass.Gov? What prompted it? I guess you sort of told us
Yeah,
about what prompted
right.
it. How did you set this up for Mass.Gov? What'd that look like?
So we set this up as part of the release process for Mass.Gov. And so like as code was going out to production, it would go through the staging environment. Again, that was sort of like a draft version of the site. And we would release to the staging environment regularly. And someone would have to do a comparison of like, does this page on the staging environment look exactly like this page on production? So we saw that as a really big opportunity, like let the computers do the work there. And so initially, whoever was the release manager that day would run this tool manually from their machine, and it would go out and compare a page on staging with a page on production and alert if any of these were different. And so, you would test like the home page, the governor's page, like any of these really like high profile pages to make sure that nothing had changed. Later on, we were able to actually tie that into the release workflow and get this automated such that, deploying to staging actually triggered this comparison to happen. And it was pretty hands off. Like the release manager wouldn't actually have to pay attention to, like any of the comparison pages except for the ones that were erroring because they had a difference. And that was a really big change for us at that time because, previously the release process was taking about, like, it was somewhere in the range of 3 to 5 hours for someone to deploy and then actually like pay attention to all these pages and try and catch these visual differences. So it saved a lot of work and a lot of time.
So 3 to 5 hours of the workday dedicated to manually testing before release, before tying visual regression testing to the release process. What did you say we reduced that down to?
Well, it's tough to measure in isolation. Certainly, Backstop was a huge part of what cut that number down. One of my coworkers, Melissa Rossi, also did a whole lot of work on the automated testing workflow and the way that tied into the automated release process, such that we got it down to below an hour. So pretty significant time savings there. And most of that is like, waiting for Backstop to finish, waiting for Nightcrawler to finish. But like the important concept there is not only did we shorten it, but we kept or improved the safety at the same time.
Yeah, that's great. So I feel like there's another benefit here that's probably not totally obvious to people who aren't sort of thinking a lot about release processes. But so I wonder if you could just talk a little bit more about when there's a lot of manual testing involved in a release, there's sort of this disincentive to do frequent releases, right? Because if every time there's a release, there's like, that comes with 5 or 6 hours of testing, we probably would rather do that once a month than once a week. We certainly don't want to do that like many days. If you do 2 releases in a week, that's like a whole person day of testing. So can you talk a little bit about the benefits of reducing the time it takes to do releases? Because it seems like that's another kind of problem, right? That creates other bugs and risks.
Yeah, for sure. I mean, it's fairly well known in like the web development industry that the smaller the releases and the more frequent that they are, the less risk they actually carry. That's sort of counterintuitive. I mean, when you sit down and think about it, it's like, well, if I'm just pushing less, I'm probably testing less, I'm probably paying less attention. But realistically, smaller releases mean less going out at once. So you're testing smaller units of work. It's also kind of impossible without like some level of automated testing. And so really, like, our goal is always to speed up that release, make it possible to do faster. I think the other kind of disincentive that I would just call out here too, like there's obviously the difficulty of release makes it less likely to happen, but there's also something that happens on the development team where you're less likely to try a change. So like something you might have tried previously, or like with a good release process, if you know that there's not a lot of like testing, not a lot of chance to catch problems with it, you're less likely to try it. And as a result, like just less gets done. So faster releases mean, more can get out and you're also able to try things. It really lowers the barrier to like doing development on a project.
Mm-hmm. Yeah. So I was just, trying to remember like what exactly was it like before. I had this vague memory that releases were every 2 weeks. They were late at night and off hours.
Yeah.
And I don't know exactly what it was later, fast forward a couple of years, but certainly weekly, maybe a couple times a week. We definitely started doing releases in the middle of the workday. I don't know if you want to add any more color to that description, but it was a pretty big change, wasn't it? Just like the cadence of the releases.
Yeah, I mean, I think you pretty well nailed it there. The only other thing I'd add to that is, there's another type of release that no one wants to think about, which is the hot fix. Like, what happens if we push something out? And so that was, like if we broke something on a page and we had to spend 4 hours, like let's imagine we broke the homepage and we have to spend 4 hours testing before we push to production. That's a really bad thing. And we probably can't do it during the workday because, we need to spend 4 hours, like it'll happen after the day. So that might be 4 hours that the homepage is broken. Anyway, yeah, we were able to get hot fixes out directly during the day. I can't remember exactly when they're doing releases now, but it's fairly frequently, and it's much more of a non-event. I remember one of my coworkers calling it a nail-biting experience in hindsight, this release process, and now it's just pretty low-key.
Yeah, great. Just to be clear, I don't think the homepage was ever broken for 4 hours.
No. That's just a hypothetical.
Okay, great.
We would never do that.
Great. Why don't we take a few more questions about visual regression tests and Backstop? All right. So I see. Can we bring that question back up? Would you use Backstop today? Right. So this is a few years ago. Is there anything that you've learned about visual regression testing that might lead you to a different tool today?
Yeah. No, I probably wouldn't use Backstop today. There are newer tools out there. The one that really jumps to mind is Playwright, which is actually mostly an end-to-end testing tool, but it drives a browser in much the way that Backstop does, but it allows you to script a lot more complex automation. So like a lot more complex interactions. So for example, like let's imagine that you're not just taking a picture of a static website, a website that like looks the same no matter what. Let's imagine that there's a login component and you need to take a picture of a page that you need to be logged in for. So Playwright would allow you to sort of script that entire interaction, hitting the login form, punching your credentials in, hitting the login button, and then visiting the page, then screenshotting and comparing. Whereas Backstop is much more just pointed at a URL. So I wouldn't use Backstop today.
Great. Next question. When developers make changes to the site, do the same developers update the tests? Or is that a different team with a different skill set?
Yeah. You can go two different ways with this. I think the best case scenario is usually the tests remaining close to the developers who are doing the work. So having developers update the tests alongside their changes. And that way, as a reviewer, I'm able to see not only like the change that they made, but also what effect does this have. So in the case of like visual regression testing, this is a really cool one where as a developer, when I submit a pull request for that, a request to make the change, I'm actually going to update the snapshot of what I'm trying to, of the visual change that I'm trying to make. You know what? Actually, scratch that. That's a whole separate workflow that is a little bit more complex. But I guess the point that I want to make here is that as a reviewer of a change, I'm able to see kind of like how does it affect the tests, and the tests should be driven by the way the site is used. So, you know, pages or workflows that are used by users of the site.
Great. I heard you say there are two different ways. And so I thought where you were going is like, you know, sometimes the QA team is updating the tests, and sometimes it's the engineers doing the work. And then you mostly talk about it's the same people. I wonder if you could just sort of tease apart the two different ways. And I don't know if you have a preference, if one's better, if one's better in a certain circumstance versus another, but that'd be interesting to hear.
Yeah. Okay. So I think that in general, it's preferable to have the people doing the work update the tests. I think there are a few reasons that like you might want to go with another approach. One reason would be if you have a big distributed system and the developer is working on one component of the system and the tests are crossing many components. And I think we'll get into an example of that in a few minutes. I think that the other reason that you might want to have the developer not be the one updating the tests is if the tests are actually designed to be acceptance tests. So like business acceptance tests might be beneficial to have like business people writing sort of like the logic that drives these tests. And as an example of that, there's a tool called like Behat is one, Cucumber is another tool that's out there. And so like, these are tools where business people can write human language tests that then get executed in code. And so like in that case, you actually want your business people to write those tests because they're the ones that are writing the acceptance criteria.
Got it. Great. Okay, and that was an awesome segue to the next story I really want to ask you about. So I'm going to bring us back to that. I'd love to talk to you a little bit about, you know, more complex use cases for end-to-end tests and some of what we saw on PaidLeave.Mass.Gov and the really excellent infrastructure that you put in place there. So PaidLeave.Mass.Gov is the website that we helped the Department of Family and Medical Leave make for workers and employers to submit claims and to manage benefits when paid family and medical leave went live in Massachusetts in 2021. And so, you know, we can cover a lot of bases with error checks and visual regression testing. can you just like talk a little bit about why we need something else? I feel like you sort of referenced it with the Playwright and many components, but can you just sort of help us understand why do we need something else, and what more is there?
Yeah. So so far we've talked about two types of tests. We've talked about really sort of like basic error checks, and then we've talked about visual regression tests. We haven't really gotten into the functional realm yet. Mass.gov in particular was like there's not a lot of interaction on the site. It's not a place where you go log in. It's not a place where there's a lot that you can interact with there. PaidLeave was a different story. PaidLeave, the application, exists so that people can go file for benefits. And so that process is necessarily entry of data into the system and then some interaction behind the scenes. And so when they enter data, they're entering it into one system. It goes into kind of another system. And then behind the scenes, I'll kind of walk through this workflow, I think, in a minute. But there are 3 or 4 different systems involved in this workflow of someone actually submitting a claim and getting paid. And if you think of those 2 things as like the beginning and the end, someone submitting a claim and receiving a payment, we have to cross 3 systems to get there. And so like tests that we write for a single system are no longer sufficient. A single system can be working perfectly, but it needs to be wired up to the system beside it perfectly as well. So these end-to-end tests allow us not only to like test the functionality of a single system, but also the way it connects to all these others and the pipes that are in between those.
Mm-hmm. So would it be accurate to say, in the same way that a minute ago we talked about, like you could have a bug that does not generate an error, but it's visual.
Yep.
Would it be accurate to say about scenarios where you need end-to-end tests, it's possible, maybe the bug does cause an error and maybe the bug is visible, but maybe we have a bug, someone's not getting the payments they should be getting, for example.
Mm-hmm.
Maybe there's a bug in the system that is not tripping errors and is not visible on a screen that someone's looking at, but like the pipes are broken, and this is like a different category of bug.
Yeah, that's definitely true. So just to kind of put a point on that and give an example. So let's imagine, my friend comes in and she just had a baby, and so she's applying for bonding leave through the PaidLeave.Mass.Gov application, and she submits her claim. And what's supposed to happen is when she submits her claim, her employer gets a notification. Her employer needs to respond. Once her employer responds, that goes to the Department of Family and Medical Leave. They go in and they perform some activity on the claim to just sort of like make sure everything's in line. And then they come in and they approve the claim. And then she ultimately receives a notification, and then later on her benefit. And so there's a moment there where her employer has submitted the claim, and it goes into a queue for someone from the Department of Family and Medical Leave to review. And as an example of like how things might break or what that might look like, let's imagine that the employer responds, but then that never ends up in the department queue to review. And so no one ever knows that that claim needs to be approved. No one ever sees it. And she basically just like doesn't hear anything back, and the whole system breaks for her. So individually, all those sort of systems might be working, but the employer system that was supposed to forward that claim on to sort of the system that the department interacts with isn't connected. Mm-hmm. So like that's an example of something that might break along the way. And so end-to-end tests are actually like really good at catching that kind of thing, because they might follow that entire journey by using a browser. They'll use a browser and they'll go from the claim intake application, act like the employer, and then come in and as an agent look in the queue and make sure that that claim is sitting there. So like they would catch that kind of failure because they'd be sitting there waiting for the claim to arrive. It would never happen. And then they would know, we would know, hey, there's a problem. And I guess that's one other sort of like thing to mention about end-to-end tests is they're very good at detecting that kind of pipe breakage. They're not always so good at telling you why.
Mm-hmm.
So like you can see that the claim didn't arrive, but you don't know anything more about it.
Mm-hmm. Got it. So you said with end-to-end tests, you can, behave like this user and then behave like that user to sort of step through the system. Can you just talk a little bit more about how that works? You said earlier that Playwright is an end-to-end testing tool that you like.
Yeah.
Is that, could you tell us whether it's about Playwright or about a different tool? Can you just help us add a little more color to this picture of how does someone make one of those tests? How does someone maintain one of those tests?
Mm-hmm.
Is this specific to the application that I built? Like maybe I can use Playwright with this application and not with this other application. If I've never made an end-to-end test and I want to know, like, what does it take? Can you help me understand what I might need to do to make something like what you described?
Sure, I think so. So example of a Playwright test. Oh, well, I guess let's start with the foundational stuff. So Playwright, and there's another tool out there called Cypress that functions pretty similarly. Playwright allows you to script interactions with a website, and so that's not necessarily any kind of any underlying technology. You can script interactions with a PHP website, JavaScript. It doesn't matter what is behind the scenes. It's actually driving the browser, and so you tell the browser what to do. So that's kind of like foundationally how it works. So you just drive a browser through a workflow. It's not going to be specific to, or the tool itself isn't specific to the application either. It's just a generic like browser automation tool that we use for end-to-end testing. And so what that might actually look like is, we think through what is the actual user journey of my friend applying for bonding leave. We build out a scenario that sort of has all those different components. What is the employer going to say? What is the department going to say? And we go through and we script those interactions kind of one by one. And once all that is linked together, you sort of have like this big picture user journey that follows that trip through. And I think one of the beautiful parts about this kind of testing too is that it's really user centric. Like we're focused on what does the user see at each step, and who the user actually is changes. So it's my friend in the beginning, it's the employer in the middle, and the agent at the end. But it really is focused on like the outcomes rather than the how do we get there.
Mm-hmm. Great. I wonder how it compares to Backstop and Nightcrawler, the error checking and the visual regression testing. Is it a lot more complicated? Is it a lot bigger of a lift, or is it, can you just sort of compare how easy or how difficult is it to create these end-to-end tests compared to what you described at the beginning of our conversation?
Yeah. I think Backstop and Nightcrawler are both really like straightforward tools to use. Just on the time investment, like Backstop and Nightcrawler, you could probably set that up like with a small group in a quarter, no problem. I think like end-to-end tests tend to be much more involved, and really that depends on what you're testing. So in the example of paid leave, that is a pretty complex use case. Like we're going through a lot of different workflows as a lot of different users. There might be mock data that's needed. So the time investment for testing something like that is definitely a lot higher. In terms of skill level and like who you need, Backstop and Nightcrawler are definitely like on the lighter lift side there too. They're pretty simple JavaScript-based tools. They work on a single configuration file, so not all that difficult to set up. So end-to-end testing is definitely going to be a heavier lift, just because you need to start grappling with questions of like how do we set up mock data? Do we pre-populate the environments with fake logins, that kind of thing, and then like what is the actual business flow we're going to need to follow? So it's a lot more there are a lot more dimensions to pay attention to, I guess. And, it just takes a lot more. But by the same token, you also don't need to follow. So end to end is subjective, and you can pick your ends. You can pick, I'm just going to automate like an entry of the claim into the claim intake application, or like if your application is simpler than that, like you can automate chunks rather than going all the way to the end as a way of taking small bites at the apple.
That's a really helpful point. Is that maybe a more practical place to start for people who are just getting started?
Yeah, I think if you were starting with this, I would not advise starting with a paid leave. I would advise taking a much smaller bite, like automate the intake form and just go through the, submission of a claim there, for example, or small chunks.
Cool. Sounds like good advice. Maybe this is a good place for us to open it up to folks who have questions again, and see what other people are wanting to ask about. How did you get buy-in to develop this DevOps infrastructure internally?
Yeah. Well, first of all, you have to have really good stakeholders. So just a shout out to Brian for really like seeing the vision in this. I think also that you don't start out by looking for DevOps infrastructure. If you're starting there, you're probably looking in the wrong direction. I think we're looking for outcomes, right? So like on the example of errors on Mass.Gov, like we're trying to reduce the times that someone visiting the site sees, something went wrong page ultimately. And we're trying to improve the stability for people. And so how do we get there? We reduce the errors. How do we reduce the errors? We implement, a crawler. So I think I would start from first principles there, like what are we actually trying to solve? And then work your way back to the solution.
All right, next question. For states that purchase software, what should we be looking for to ensure our partners are doing their due diligence?
Yeah, I think this is a good question. I think that you would like to see that your partners are knowledgeable about automated testing and also the why of automated testing. It's not enough just to automate. You need to understand like what's the purpose here, and it's ultimately probably should be to move faster, get more done, increase stability, increase safety. So look for a thorough understanding of that and really experience implementing it. I think is a big part. I think that it would be a green flag for me if I saw firms that have a firm understanding of like DevOps principles of like, single piece flow of, these are sort of like principles we didn't really cover very deeply, but there's a whole movement around this like release early and often philosophy that I think I'd be looking for a firm that I'm trying to partner with to understand.
Great. Do we have more questions? How often do end-to-end tests run? Yeah, we didn't really talk about how, like in paid leave, like maybe you could connect the dots all the way to the release process. I'm sorry. Please answer the questions on screen, but
yeah,
I wonder if you could
sure.
also tell us about how it relates to the release process.
Yeah. So end-to-end tests for PaidLeave.Mass.Gov, we ran end-to-end tests with every merge domain. So that would be every single time that we deployed to the dev environment. And so that is good and bad. The reason that we did it that way is because we needed an actual environment with, all the components set up, because it's end-to-end testing, like we're crossing all these components. You can't really do it in a local environment. You can't really do like a test of anything less than like all the pieces. And so we would run it on merge to main, and then we would run it immediately prior to release as just a sanity check. And it became really good at detecting like environmental breakages as well. Like if, for example, if we had a new environment set up, we would immediately run the end-to-end test suite to make sure that that environment was up and functional. So yeah, on deployment and on merge is the answer there.
Great, thank you. I wonder if we can squeeze in one more, and then yeah, let's see if we can get one more up. All right. Are you copying data from production to the test environment where tests run? What do you do about PII and PHI?
Yeah, this is a really good question. The data aspect of this is a whole other ball of wax. The short answer is no. For this project, we were not copying data. We had a mock data setup process that would generate realistic data. We had this done all the way through the point of like, there were these PDF forms that needed to be submitted with a claim. And we would actually go in and generate like a fake PDF with a fake signature of Theodore Cure, who was our doctor. So we had like a fairly robust system for providing this mock data and making sure that it was populated in the environments. We didn't try to pull things down because we didn't want to deal with PII or PHI or any of that stuff. So yeah.
Great. Okay, we should probably pause questions there. Thank you so much, people who submitted questions. Before we go, I have an announcement that I'm really excited to share. So I'm going to just bring it in at the end here. In 2024, AgileGov is launching a mentor program, and Rob Bayless is going to be one of our mentors. So for product and technology leaders who are enrolled in our 12-month program, Rob will be leading some of our sessions and mentoring some of our folks. So we welcome new teams into AgileGov quarterly. If your team might be interested to join this spring, please let us know through the feedback form. And that's a good segue to the QR code and the link for the feedback form. Please, before you go, if you could snap that link or go to this URL. Really value people's feedback and would love to hear what was the most useful, and then any suggestions for how we might continue improving these live streams. Rob, thank you again so much for being here. Really great to talk to you, and I'm so excited to have you in our mentor program and see where we go with that this year. Thank you so much.
Thanks so much, Brian. It's great to be here, and I'm looking forward to the mentor program.
Okay, thanks.